window if you can hear me. And went through the course content that we have provided in the PDF format. So if you have any questions from the initial video and from the course content, you can post them now. So we will take all those questions during this session. So this session is divided into few parts. So after every part, actually it's 4 parts. So after every part, I will pause so we can have a session for question and answers. Okay. So we can do the Q&A. Okay. Okay. Agenda for today is we mainly cover the 5 items. The first one is data is new oil, and why data science. Can I learn? I mean, can you learn data science? Then we cover the data science program. What are the contents we are going to cover in this course and the duration. So most of the items we cover there. Then we see the data science in action. So I will show you a quick demo, and also we will run through few of the algorithms in the session depending on our time. I'm trying to cover whole session in 1 hour or 1 hour 15 minutes. Then we have some time for the Q&A. Okay, let's start with our first topic. Data is new oil. So nowadays people call it as a new oil, but why do they call it as a new oil? Do you guys have any idea? Okay, because all these big companies like Google, Amazon, Microsoft, Facebook, they have captured a lot of data. So using this data, they can produce a lot of analytics, and they can provide some very good, meaningful insights for the market. So let's see in detail. Okay, if you look at the slide here, the Facebook share is falling. This is, I think, from yesterday. So on March 16, the price was $185. Okay, and coming to March 26, the price is 160. Do you know the reason why the Facebook share is falling? Don't worry, we are not going to discuss much about the shares, but what's happening with Facebook recently, last few days? Yeah, that's right. Mr. Badri answered correctly. Okay, it's all about Cambridge Analytica. What is this Cambridge Analytica? Okay, this is the screen capture from their website. So what do they do? Data drives all we do, right? So they just work with data. Okay. They use the data to change audience behavior. So they are changing the people's behavior actually. The sentence is very strong, right? So they can use data to change the audience behavior. Audience is people. So they're promising that they will change the people behavior. So this is their homepage. You can go to their website and you can view more about them. Okay. So what has happened actually with the Facebook? Okay, there is this guy called Alexander Kogan, okay, who is a neuroscientist in Cambridge University. What he did is developed a simple application. It's a personality quiz and posted on the Facebook. And some 320,000 users has used this application and provided the survey. It's like a survey. So, but all these people has been paid $2 to $5, in the range of $2 to $5 in 2014. So this application, what it does is, when these users filling the data in the backend, it has collected data of, because they need to log in using their Facebook account. So what happened was, this application also collected data from these Facebook accounts. And it's not just 320,000 Facebook accounts, because this 320,000 users has friends. Okay, so this guys has a lot of friends. So every person has few friends. So it has collected data even from them. So all this data this guy has collected, and he shared to Cambridge Analytica. So Cambridge Analytica has the data of almost 50 million users, and the survey results from 320,000 users. So what Cambridge Analytica can do with this data? So what they did is, they, based on the results from the survey, and also the collected data, all their personal tastes, based on this data, they know if this person X, they know what does this X do on Facebook, which are the posts he like, and what are the posts they share, and the comments they respond to, and the kind of friends they have. So they have all this personal information, and that shows the psychological patterns of a person. So using this, what they did is, they got another database, which is voter data. Okay, so this is during the Trump campaign. So they got the data from the voter database. So they try to match the two databases together using some algorithms. Okay, and based on this, what happened is, they managed to influence the individual persons. So out of this 50 million people, they managed to influence some people by advertising by targeting the personalized advertisement. So let's say if you receive an email without your name, without any of your personal details, you don't pay much attention to it. But if someone sends you an email personally to you saying so, then you will definitely read it. You will pay attention to it. So during this election campaign, the analytics, people who are analyzing this incident now, they say that Trump has benefited. Okay, and now I think there is some inquiry commission on this, and they are investigating even Facebook. Okay, so that's the reason why Facebook share is falling. So this is the power of data. A simple application started by one person collected data about 50 million users, and it can change the election results. It might have changed. Okay, we will know in soon time. So is this happen only with one application? Actually, it's everywhere. Everyone knows the importance of data now. That's why we call this as a data is a new oil, and some people also call data as a new electricity, because it's everywhere. Okay, we will see that later more. So what did our dear Rahul Gandhi said? Okay, it's a recent tweet from March 25. So he's blaming Narendra Modi on his official app, okay, saying that he's giving the data to American companies. So BJP replied him. Okay, Rahul Gandhi is the president of India's oldest party, and when you sign up, the data goes to Singapore. So this is on March 26. So they're fighting. So everyone knows the importance of data, and this is not now. Okay, people knows the importance of data even way before. This is a famous quote from 1942. Okay, data is not just collected for the museum. purpose. If they're collecting some data, they are going to do something with it. So if they can't get any meaningful results from the data, or if there is no purpose in the collection of data, you don't have to collect the data. Okay, it's like garbage in and garbage out. So whenever people doing some survey in like some shopping mall, okay, just spend 5 minutes, you do this survey, you give us this information. So they're collecting some data from you. It's not just the data, they're getting to know what you are, and they're collecting the sentiment in that location. If they have the 10 people in the same location giving the same information, means they know the sentiment of that location. So they can do in multiple places to know the market sentiment. So this is what happens with the data. So if you have data, you can do a lot of things. Okay, right. So I have data. Okay, and now we know data is a new oil, and we know what is the importance of data and how everyone fighting for it to get the data. So once I have the data, so what can I do? You can do lots of things. Okay, every industry needs data. Let's say healthcare, you can identify diseases if you have new data. Okay, and personalized medication, if you have a genome, your genes details, based on that they will know what are you allergic to, and they can analyze your hereditary and see what are the diseases you are prone to in the future. So they can analyze a lot of things with the right data. Okay, data means not the garbage, it's right data. Okay, if you take the banking fraud detection, what happens when you swipe your credit card? Let's say you are going to a different country which you never been to, where you did not use your credit card before. Your credit card may not work. You might need to call your bank. Hey, I am in this country, so can you activate my card to use? Right? Because maybe there are some if you go to some other country, your credit card may work, but some places it may not work. Especially if you go to some new country and you go to a casino, definitely your credit card may not work. What's happening here? The bank is detecting instantly there might be a fraud. Somebody might be using your card. Okay, and the risk modeling. This is where the data science and machine learning is very much used in the market now, and also your credit scoring now. Okay, coming to the marketing, so predicting the lifetime value. Lifetime value means, let's take Apple. If there are a lot of people who are very loyal to Apple products. They keep on buying iPhones, one version after another. There are a lot of people who just buy iPhone, even though there are very few features different between one version and other version, but they still want to buy because they are very loyal to the product, and they want to buy the product on the day one itself. So if they have this data, let's say Apple realize that they have some 500,000 users who are very loyal to them, and whom they predict that lifetime they are going to be with Apple products. So they can even predict their revenue for future years, and they can plan based on that. And they can also study these users separately to see what are the features they can offer to the other customers and why these people are staying with them. Okay. And customer segmentation. This is another key area. Every company has different customers. The mobiles, you have that different customer segment. You can segment by age, like teenagers, like old above 60, the senior citizens, okay, or even below 10. So they can target their products based on the age group. Let's take Japan. Japan has a lot of older population. The population is getting older and older, and the child births are very low. So I can't go and start a business for the children there. But if I start a business for the with the products that may sell for the older people, I might do a good business. So all this analysis you can do if you have the data. Yes, so there are a lot of things. Another important thing here is, recently, if you have seen, it's a resume screening. You might apply for 100 jobs, but you may not get any reply. So what's happening? It doesn't mean that you don't have the skill. It means the software or the algorithm that is screening your resume, and you may not be aware that some algorithm is screening. Maybe you are thinking that a person is screening. So this is now every company is using, especially in Singapore. There is a one famous bank in Singapore, DBS. I think they have a branch in India also. They are using machine learning in HR while hiring the people, even the retrenching the people, or even the retaining the people. So they screen what happens is they collect all the resumes in one place, and they rank the resume based on the requirements. Let's say they have a new role, they supply the job description to this algorithm. Based on this job description, algorithm will go and rank all resumes, and it gets, let's say, top 10, top 20 for the interviews. So this is saving a lot of human effort as well as lot of cost. Okay, so once you have data, you can do a lot of things. But how to do this? We are talking a lot on the algorithms, okay, a lot on the data science, machine learning. So what are all those things? Okay, let's see. Data science. Okay, the course is about data science. So why data science? Why are we even calling it as a data science? Okay, we will know this later on the subsequent slides, why we call it as a data science. But why data science and why now? So we know that there is an importance to data from 1942, but nobody spoke about data science even 1980 or 1990. But why people are talking about it now, and why there is a huge demand in the job market right now? So this is from the 2018. We have the report from Glassdoor, we have a report from LinkedIn, and also McKinsey. Okay, everyone says there is a huge demand for data scientists. But why? This trend is not there in 2014 or 2009. Okay, we need to see we need to consider few items, okay, before we understand why there is a demand now. The first one is people and devices. You can say even people versus devices. If you look at this chart, the orange bar represents the population. Okay, this represents the devices. Okay, and this is the, I say just internet connected devices per person. Okay, this is per person. So if you see in 2003, the world population is so huge. Okay, but the devices are very less, and the internet connected devices are far less. Okay, and in 2015, if you see, the world population is 7.2 billion, but internet connected devices are 25 billion, 3.47 devices per person. So every person has more than 3 devices in the world which are connected to internet. Okay, in 2020, the expected is per person 7.58 devices. So just look around you on your table, how many devices you have that are connecting to internet. If I look at my table, I have at least five devices that can connect to internet just on my table, not at the, not in the whole entire house. So I have more devices. So what does it mean? It just means more data. There are more devices means more data. So devices are generating more data than humans now. Okay. So what is this data? Okay. If you see here, in 2020, the expectation is more than 40,000 exabytes of data. And among this data, I think almost 80% is unstructured data. Okay, 20% is structured. Structured means the data is already in a well structure, which you can analyze very easily. But most of the data is unstructured, so it is not easy to analyze this data. You need some additional skills to analyze this data. That is what big data. Okay, so based on the big data technologies, it is expected almost 30 to 40% of data will be analyzed in 2020, whereas it was far less in 2015 or even 2010. Even in 2010, even the collected data itself is very less. It's only 1,200 exabytes. So what does it mean? So we have more devices now collecting the data, and the data volume is growing exponentially. Okay. Okay. When the data is growing, how much it costs to store this data? Okay. If the data storage costs more, nobody want to save the data. Let's say you have 1,000 photos on your phone, and your phone is running out of space. Definitely you will delete some of the old photos, or you will back up somewhere. And if you don't have any place to back up, you have no option, you have to delete some of the photos, because the cost of storage is more than the value of the photos. Okay, if the value of the photo is more, then definitely you will go and buy the additional storage. So, but what's happening here? From 1981 onwards, it is continuously decreasing the cost of the storage. In 1981, the storage cost is 700 per MB, but now it is only 0.02 cents, 0.002 cents. So it's very, very less. Actually it's very negligible amount per MB. And the final thing, which is the processing speed. Processing speed is increasing. So the amount of data you can process today much higher than, let's say, 1970. Okay, and the Moore's law says that processing speed doubles every 2 years. So you can see every 2 years Intel comes up with the new processor, says that okay, this processor performs 1 times faster or 2 times faster than the old processor. So what does all this mean? So what did we see so far? We have seen, okay, we came from here. There is a huge job market. Why there is a huge job market? Right? There is a demand for the data, and there is a data growth, and data storage costs nothing. So people can store more and more data, and they can process more and more data now because of the high processing speeds. So this is one reason why now we are talking about the data science. I can't talk data science. I may not be able to talk, I wouldn't be talking about data science 10 years ago, because even though I talk at the time, nobody will listen to me, because they know they can't process that huge amounts of data. They know they don't have technology to process unstructured data, but now we have it. So that's why there is a huge demand for data science. Okay. Okay. So far, any questions? I will give a quick break here. Let me see if there are any questions.
Kishore, Loganathan has posted a question. I hope you can view that in the questions pane. Just click on the question mark on the attendees list. You will be able to open the questions pane. Anybody's on anybody's. There is a question icon is there. Just click on the question icon.
I can see the question, but I can't completely see the full question. I can't expand the window. Can you just read the question?
Yeah. Question from Loganathan is, I have a question. Was the data collected from LinkedIn also? I have communicated Singapore HR, but no response. We can discuss later. Yeah, I think.
Collected from LinkedIn also. No, which data is it? Are we talking about Cambridge Analytica?
Yeah,
Loganathan?
better. Loganathan, if you are interested, please raise your hand. I can unmute you so that you can ask question via audio. Yeah. I'm just unmuting Loganathan Kishore. Yeah, go.
Yeah.
Hey, Loganathan, please go ahead.
Thank you for the help. So my name is Loganathan from Salem. I'm from Tamil Nadu. So actually, I'm looking for a job in Singapore. I have communicated to the HR in LinkedIn. So I did not get any response. Means based on my name, they will track my all the data in the LinkedIn also. But I'm not sure about the Cambridge, which you explained me. But
no, Cambridge is different. Cambridge
okay.
is especially, they are mainly targeted in Europe and US markets. And
Okay.
it's not about the LinkedIn. What they wanted is they wanted to know the people psychology.
Okay.
So they mainly targeted Facebook.
Okay.
So LinkedIn is not involved here.
Okay.
Yeah, Loganathan, if I am not wrong, sorry to interrupt, Kishore. Is your question is like, you have posted in a LinkedIn and via a data science or some mechanical or algorithm process, whether my resume is being screened or not, that is your question?
Yes, you are right.
Yeah, Kishore, that
No,
is his
definitely.
question.
Okay. Loganathan, okay. Your question is different. Okay, what you're asking me is, you have posted your resume to the HR. So you are asking me if your resume is went through this algorithm process to scan, right?
Yeah, actually, I did not post a resume itself. Just I chatted. I'm looking for a job. Not even posted my resume. I contacted HR through chat page, and there are almost 20 or 30 people I contacted. So, but at least I did not get any response. Means they are not even asking some. Okay, what is that? Where are you from, or something? Or is that chat is
Loganathan, there could be many reasons for this, because you can't just put it on the machine learning.
okay.
Because there could be many reasons. There could be many reasons, like the HR, the company is not recruiting anyone from India because they might have some quota. They might have some quota. So because the government makes some agreement, okay, you hire from Philippines or you hire from Indonesia or Malaysia.
Okay.
So there are some quota allocation in Singapore, especially. So it may not be the machine learning issue.
Okay. Yeah, I got it.
Machine learning, they need to collect some data from you. If you're not getting any data from you, they can't use machine learning at all.
Okay.
Since they haven't collected any data from you, so we can't suspect anything just because of the machine learning.
Okay. Yeah, I got it now.
But there is a possibility, right? I mean, based on his LinkedIn profile, my company is a big MNC company and I'm using, the algorithms. Now will it be possible via his LinkedIn, can I check it in the Facebook and what are all the activities that he has performed in the LinkedIn? Is there any
Yes,
possibility?
of course.
Yeah. Right.
Yes, there is possibility. That is called talent searching. There are some machine learning algorithms that machine learning bots, they call it as a bots. So they scroll through the net and they find for the right talent with the right skills. So they scroll through. You may not notice them. Even let's say Google, right? If you are using Gmail, Google scans, reads all your emails, and you won't know it that Google read your emails. So that's why most of the people don't like to use Gmail or Yahoo nowadays. They want to use their own personal email.
Right. All right. Yeah, I'm done from my side.
Okay.
Any others has any question? Thank you, Loganathan. I'm just muting you.
Guys, I'm
Anybody?
going a bit faster. If you because why I'm going faster is we have a lot of material to cover, and this session will be available later as a recorded session, so you can view piece with your own time later also. But if you really think I need to slow down at certain places, please ping Devender.
Yeah, Kishore, I feel comfortable, and I hope everybody are comfortable with that. I don't.
Okay.
We don't feel you are going with a pacey, but yeah, it should be fine. Anybody has? You can raise your hands, my dear friends. Badri, Fayazu, Gopal, Ismail, Kapil, Logunathan I have already done. Praveen, uh, Singh, Saha. Anybody has? Tirupati, Vasu. Around 14 more participants are there, excluding us, Kishore. Yeah, you can go ahead.
Okay.
Yeah, I'm meeting.
Okay, fine. So guys, what we have seen so far is we have seen why data is considered as a new oil and what is the importance of data, because data is our raw material. Every company needs a raw material, right? So if you want to be a data scientist, data is your raw material. So we know the importance of data now, and we also know that it costs nothing to store data nowadays, and we have enough processing power, and we have enough devices that generate data. So you have the data, you have the processing power, you have the storage capacity, you have everything now. So let's go into the data science. Okay, what is the data science? We will see what is data science on the next slide, but on this slide what I would like to cover is the whole process, roughly what happens. See, this is the collection, also called data acquisition. So this is very important. Okay, I can collect data from anywhere, a traditional data warehouse or distributed Excel spreadsheet. Let's say I have data coming from 10 different companies, or I have a big company like Reliance Industries. They have many sub companies, and everyone may not be using the same database. They have different systems. Some people may use maintain data in Excel. Some people may maintain data in the flat files. So all data should come in one place first. Okay, if you don't have data in one place, you can't proceed further. Okay, and also you have the big data, not just the data. So you have unstructured data, you have the social media. You can read all your Facebook and your tweets, and also various survey results. Okay, and data coming from the sensors. Okay, this is a very key unstructured data nowadays. What's happening, right? There are a lot of sensors installed everywhere, even in the buses. Okay, to know what's happening and to get the data real time and to monitor. Let's say I want to know the condition of the traffic. So based on, I will install the sensors in various places where I would like to know. So especially in London now, every road has lot of sensor. Even the car is traveling on the road, they can estimate how much time it takes for this car to reach from this traffic light to next traffic lights, because they have sensors on under every road. Okay. So once the data is collected, data has to be organized. So this is where data scientists spend more and more time in organizing the data. Okay, 80–90% of time, data scientists or people who are analyzing data will spend in organizing the data, because some data may be meaningful and some data may have some junk, or some data may have some null values. So you need to handle all those data. You need to have a proper data set before you start analyzing it. Then once you have a proper data set, you will build your model. So once you have your model and you will pass your data to the model, and you will simplify further. Okay, once you simplify it, this data will provide some meaningful insights. Okay, based on these insights, the managers can take the decision. Okay, some decisions may be automated, like stopping the credit card transactions. Okay, some are automated and some are collaborated. Okay, so this is the very high level picture of the data science, the whole data science together. Okay, I have two Venn diagrams here. This one you can say version 1.0 and you can say version 2.0. Okay, so what does the data science contain? Guys, this is very important slide if you really planning your career in data science. So you must pay more attention on this slide. So this will also tell you if you are, if you really, capable to learn data science, or you can proceed to learn data science. You can make your own decision. You don't have to ask someone, oh, tell me the market is good in data science. Can I learn data science? Okay, do I need to learn anything else before I start learning data science? So all your questions will be answered on this side. There are three main circles: computer science, mathematics and statistics, and business domain experience. So data science is nothing about all these three. So it's not one item. Let's say previously I want to be a .NET programmer. I can just learn .NET. I want to be a Java programmer. I can just learn Java. I want to be a project manager. I can just learn project management. I don't need to know much about the technology. Either still you need to know some technology, but not much. Or I want to be a business analyst. So once, if I have the enough financial knowledge, I can go into a bank. If I have a telecom knowledge, I can go into a telecom domain to be a business analyst, even though I don't have much experience on the technology side. But here it is combined. So you need skills from computer science, you need skills from data science, and you need skills from business domain. So you need skills from all the areas. Let's say if you have skills in the computer science as well as business expertise, okay, if you have these two skills, it's nothing but traditional software. So that's what everyone doing, right? If you develop an application like Java application, you have someone giving you the business requirements and someone give you the solution architecture and someone will code it. So the people from here and here are interacted. So where we develop a traditional software, okay, there is no need for any mathematics there. Let's say I have the skills from computer science and I have a mathematics, that is called machine learning. I don't need to know about the business knowledge. Okay, I have the skills and I know how to do mathematics. So somebody will tell you, okay, how to do this. So somebody gave you some data. You don't know what data it is, whether the data is meaningful or not, but still using your skills, you can find some insights on the data without knowing anything about the data. That is machine learning. So it will extract some insights from the data. Let's say you don't know anything about computer science. You know about mathematics and you are very good in business domain. That is called data analysis. So to analyze the data, you really no need to know any programming language, right? I can put some data in Excel and I can see the data. I can tell. Do you think all those people who are trading the shares, who are earning a lot of money by selling and buying the shares, do you think they have some programming knowledge? But they do apply some mathematics and statistics. They do calculate some stuff. Okay, they have some algorithms that they do calculate. Okay, they see the trend, how the share market is going. So what happened last year or what happened in the similar situation. So they compare, they use their experience. Okay, they use their domain expertise because they are in the market for maybe 10 years, 20 years. So that's about data analysis. So all together is data science. So same way in version 2, what happened is they removed the term data science. If you see, traditional software remains, and data science, data analysis has changed to traditional research. Okay, because they are doing the research based on the statistics and mathematics. Okay, and instead of business and domain expertise, they're calling it as a subject matter expertise. So they are limiting it. So they may take only one term, so rest remains same. Okay, unicorn is like, do you guys know what is a unicorn? So you just Google for unicorn. So they feel like a unicorn if you know everything. So can I learn? Our next topic. So can you learn data science? Yes or no? Now you can decide yourself. Let's say you don't worry about any prerequisites that you need to learn. Let's go back to our slide. So you think where you are. Are you here? Are you here? Are you here? Or are you here? Are you here? Are you here? So you know what else you need to learn. So if you know one programming language or two programming languages, and you know how to code, and you know a little bit of computers, you are here. Okay, either you are coming from the college, you know you are very good in mathematics and statistics, either you have a PhD or you know statistics very well, and you have been using on your job statistics, but you have no computer knowledge. That's fine, you are here, you can still learn. Okay, or you are pure business domain expert or subject matter expert, and you don't have computer science, so you can learn one language or two languages, and you can acquire mathematics skills, because data science does not require the complete mathematics and statistics. You just need to learn what is required for data science. Okay, we will go through that later. So you, based on this slide, you analyze yourself. Okay. So based on my experience, what I say is anyone can learn data science. Anyone, because data scientist is not one job. Okay, and in a company, not everyone does the same job, right? Everyone play different roles. It's a team. When you deliver a project, it's a team effort. So if, let's say, if I'm using a data science, I need someone to clean the data, I need someone to arrange the data, I need someone to analyze the data, and I need someone to apply the algorithms on the data, and I need someone to get the insights of the data, understand the output. Okay, and also you can see here the difference between machine learning and data science. If you mix, if you are going with computer science mathematics, that is machine learning. Okay, but if you are adding some business knowledge on for the machine learning, that becomes data science. So the person who is doing machine learning know how to create an algorithm, how to apply the algorithm, and how to generate the output, but he don't know if that output is meaningful for the business. So there should be a business matter expert to analyze the output and say, yes, this is output that I want. In data science, you need to know the output first. You need to have a right question first. If you ask the right question, then the team will go and look for the right data, then they look for the right algorithm, and they will generate insights for you. Right? Okay. So now you decide, can you learn or not? It's not a rocket science. Okay, let's go into the data science program. Actually, what do you need to learn to be a data scientist or to work with data science? Okay, let's talk on the technology side. Python and R. Okay, these two, actually, if you go and ask, it's like, you know, like in what's going with Congress versus BJP, it's like that. If you have some 10 or 20 people in one room who are the data scientists, if you bring Python and R, they will start fighting. Python is better, R is better. So it doesn't matter what you learn, but learn one, because both work same way. And the main difference is R is designed for the statistics. Okay, this is the statistical language. So from the beginning onwards, statisticians use R. Okay, Python is a pure programming language. Okay, it is generic language, so you can do anything with Python. You can do GUI programming. Okay, you can develop a web application. You can analyze the data like images, like videos, even the audio. Okay, most of the websites, actually you name a website, those websites actually built with the Python. Let's say Dropbox is completely made of Python. Netflix is by Python. So most of the top websites made of Python. I think even Facebook is with Python. Okay, so that's why what we are doing is we are preferring Python, because this is the language for everything. Okay, initially when R was developed, Python was not so famous. Maybe like 10 years ago or 6 years ago, R was very famous because every statisticians want to use R because it's an open source, it's free. The other packages like SPSS or even SAS are more expensive. So everyone started using R, and they have a lot of packages, so a lot of resources. Because if you want to learn a language, you need to know how to program in that language. So you need enough resources to learn. If you don't have any resources, let's say if you want to learn one language like German, you need to have people who are speaking German beside you, or you need to have some material which is German beside you. Let's say if you don't have all this material and the people don't speak German, after a few years nobody will speak German. Everybody will forget. Same way for the languages, for the computer languages also. So what happened later on, the Python has developed, they have lots of packages now. Actually they have more than R now, so it's better than R. And another good thing is Python is very easy to learn. Okay, later we will see some code on the Python if the time is sufficient. So we start with Python, then we continue with R. So we are covering Python and R in our course. The next one is Tableau. Tableau is one of the top data visualization tool. So if you are presenting data in the graphs and charts, you must know Tableau. So if you want to be in the field, you must learn this. Okay, we will be having a separate course on Tableau later on. After, once we start this course, we are planning to introduce other courses. So Tableau is our high priority. Then SQL. I think most of the people who has some experience, like 3 to 4 years, they will be very good with SQL. They somehow, because every project needs SQL. Without every database, you need to query the data. So you might know the SQL. So you definitely, if you don't know the SQL, there is a lot of free material available. You can learn SQL. This is must for a data scientist. Okay, this is not must for our course because we are going to cover everything in Python and R. So we are not going to use much of SQL, but you must learn SQL. Okay, and Excel. Why Excel? Excel is still called poor man's ERP. Okay, so if you go to any company, a lot of people still use Excel, and Excel has many features which are hidden. So most of the data analysts still use Excel because it's cheap and it can analyze the data very well. Okay, it has all the features other than very like Tableau visualization, like drill throughs, but it has most of the features. So Excel is still famous. So if you want to do something very quick, you can still use Excel. Okay, so you must know the Excel. Okay, the second layer is Spark, which we cover in this course. Okay, and MongoDB it's a NoSQL. It's not must, but it's good to know this. Good to know this MongoDB, because most of the unstructured data, most of the companies use MongoDB to store, especially even the Obama campaign used MongoDB to store all the data because the response time of MongoDB is very, very fast. And the Hadoop. Okay, we do cover some basics of Hadoop in this course, not the full-fledged. You don't have to know everything in the Hadoop, but you need to know how Hadoop works, what is Hadoop, how the data is stored on the Hadoop, okay, which we will cover. All the basics we will cover, because every data science project includes Hadoop. Data, the structured and unstructured data is stored on the Hadoop, and you need to retrieve the data from the Hadoop. So you should know how to use the Hadoop at least. Okay. And the next layer, these are all like, access. I call the fashionable accessories. Okay, let's say I don't want to write code in Python. I can use Azure ML. So let's say it's just you think like your normal programming language. You write some 4 lines of code to create one button. But if you use the GUI editor, instead of writing 4 lines of code, you drag and drop the button, and this editor will develop code for you. So same thing. This is from Microsoft, SAP, and IBM. Even Amazon has their own machine learning platform. So everyone having their own platform, because for companies it's cheaper to use their platform. So it will reduce the effort to write the code. Okay, it's good to have knowledge here, and it is completely depends on the company's own infrastructure investment. Okay, but whatever you do, whatever you learn here, these are must. Okay. So I hope you all received the course content. Let me quickly go through the
Kishore, sorry to interrupt you. There are a couple of questions from Vasu. So can you go back to the slide? Can you go back to the slide, the previous slide? His first question is, you mean Python or R? Any one of them is required to learn. So it's more like, I feel, Python or R. Or do I need to learn both of them?
See, it's simply like you want to learn .NET or Java.
Yeah.
So some companies may use .NET, some companies may use Java.
So overall, one of the language will suffice.
Yeah, because some companies may use Python, some companies may use the R, but it's good to learn because the basics remain same. Your algorithms all same. You don't have to relearn your algorithms. It is just how you code, just few days of additional effort. So it is really good value add for you to know these both languages, because when you go into the market, they will split into 50-50. So if you are learning only one language, you are losing 50% of your job opportunities. Even though you know everything, it is just some additional 5% of effort that you need to put. So that's the reason why we are covering both in our course.
Yeah, you mean to say if I learn Python, R is much easier because anyhow it's a programming language, and I can just go ahead. Wonderful.
Yeah, that's right.
Yeah. And one more question.
I will come to that.
One more question from the Vasu. What is the use of Spark? That is Spark Scala. Is it the Spark Scala? You sure? Is a Spark Scala?
No, Scala and Spark both are different. Spark is mainly, it's like you will not use Python or R. You use Spark to execute your machine learning algorithms on the Hadoop, because Spark is directly connected to Hadoop. You can extract the data, and it's much easier using the Spark. Some companies just use the Spark.
So Spark is a tool, or
it's a tool also. It's tool based on the Hadoop infrastructure. It's an open source from Apache itself.
Okay.
So we will cover Spark in detail, but Hadoop we will cover basics.
Okay. Yeah. Vasu, do you have any further question? You can raise your hand to ask Kishore. Proceeding further. Just click on hand raise icon so that I can. Yeah. Vasu would like to ask question to you, Kishore. Just I'm unmuting you.
Yeah.
Hey Vasu. Hey Vasu, I think we can hear you.
Okay. So I would like to know one thing. See, in your previous slide,
Yeah, your voice is very low, Vasu. Can
Okay,
you
can
bit
you hear me
louder?
now?
Yeah, now it is okay. Yeah.
Yeah.
Okay, in that previous slide, I could see Python, R, and SQL, Tableau, so and so. I understood that these are the main technologies that to be used, and I didn't understand one thing, why this SAP Leonardo
Yes.
is related to it.
Yes. Also, I'm coming.
I
Okay.
mean,
Let
I mean
me
to
explain
ask you
you.
how it is. Means, are they having their own platform to achieve this machine learning and artificial intelligence, and
Yes.
means how
Uh,
these are
exactly. If you use Python and R, right, you can execute in your laptop or desktop. You can run machine learning. What happens, right? This Azure, even the SAP Leonardo, IBM Watson, Amazon Web Services, all these are the cloud-based solutions. So they have their own interface, like drag and drop. Let's say I have one algorithm called linear regression. So in Python, if I want to do this, I need to write some 10 lines of code. But in Python, let's say if I'm using the linear regression, I need to write some code. But if I'm using Azure or Leonardo, I no need to drag the code. I will just drag and drop linear regression, and there will be inputs and outputs like a box. So I will link my data inputs to that box, and I will link my output to this. It's a visual, like diagrams. Okay, let me just explain you on the slide.
Yeah, Kishore, can I help you on that? Hey, Vasu, Devinder here. It is more
yeah.
like it. It is more like a tool. Just 1 minute, Kishore. I'm making myself as a presenter. Yeah, 1 minute. Yeah, I can. I think I'm into the Java UI based. I have used so many tools. So you can see this tool. I hope everybody can see there. It is more like it is generating the code behind, and this is the tool. It is a web-based tool. Don't get into much. Like you know I can just create a table. I want to get a table, just drag and drop, and you can see the code has been generated here. So I think, I mean, correct me if I'm not wrong, Kishore. Leonardo, Azure are the tools where you can, the designer or the developer can use the tool, so that quickly he can develop it.
Yeah, that's right. Devendra.
Yeah, done. Thank you. So I think this
Let
makes
me
sense, right?
just,
If SAP is automating this one, then is there any need of learning these Python or R, especially?
yes, that's a good question actually. Actually, I was about to explain on the next slide. Okay, why, if SAP is automating and if Microsoft is automating, why do you need to learn? Okay, these tools are very primitive at this stage. So even though you have some tools which makes your life easier, which writes code automatically, but still you need to know the basics. Let's say you are driving a car, you know how to drive a car very well. Okay, but if something goes wrong, you have to wait for the mechanic, right? Because you don't know what is inside, what's happening. So even though this uh, tools makes your life easier by automating some of the code, still it requires manual intervention to modify the code, especially for the performance and for the fine tuning. Because when you go for the machine learning algorithms, it is very important, because even 1% performance is very good, because you are working with the data and you are trying to predict the future values based on the historical values. So if you let the system decide the code, it may not be very well optimized. So if you analyze yourself, still there's a chance of the very good optimization methods. So Devendra, can you see my screen?
Are able to view your screen.
Okay, this is a screen capture from the Azure, how the machine learning is done. So see, they got the voting data. So it's just connecting the things. So every item, right? See, they have some models called score model. They're training the model and they are using the logistics regression binary class algorithm. So when I generate this, actually this Azure generates the code in Python as well as R, both. You can just copy the code and you can execute separately. But these tools are very, very primitive and not many people still use in the production environments. But soon, I think SAP has launched Leonardo recently, and SAP will go full-fledged on Leonardo because Python, they don't make any money by by asking people to code in Python and R, because Python and R and open source, these big companies need to make some money, right? So that's why they need to come up with this tool. They just it's like, that's why we call them as a fashionable accessories, even though not required, because Python code is very simple. I can write, if I'm writing some 1,000 lines of code in C or C++, I can write the same code in 15-20 lines in Python. It's such simple and it's easy to learn. So this is just for these big companies to make money, make more money by selling their own products. Okay, but one advantage of this cloud-based solution is the whole data analysis happens on the cloud, so you don't need to own the hardware. So the companies can save money on the infrastructure. Okay, so this is the key difference between using Python, R, and using Azure. Okay, but let's say what happens in the data science is there are, let's say now there are some 12 to 14 algorithms people will use. More, maybe only 4 or 5 algorithms are used regularly, but every company, right, they are trying to come up with the new algorithms. If the company come up with a new algorithm, that new algorithm will not be present in Azure or in Leonardo. So you definitely need to go back to, you definitely need to go back to R or Python to do this, to do your machine learning using these new algorithms. And every team, if there are only 12 or 13 algorithms, why every company is not using the data science? Because this algorithm has to be customized for their own company. That is where they can win. If they don't custom, because same algorithm doesn't work for the different data sets in the different companies. You have to do some fine tuning, which is not possible using Azure and Leonardo. Okay, this may work with the small companies, okay, who ride on the success of other companies. Let's say Netflix is successful. That concept may be used by Reliance or Airtel, someone in India. So if the people are running on somebody's success, yes, these tools will work. But if they want to be very innovative, they want to have their own algorithms, then these tools doesn't work for them. Okay, is that clear? Let's move on. Let's go to the course, machine learning course. So I hope you have already went through this course. So one thing I would like to highlight here, when we designed this course, we paid much attention to the content of the course. What contents we need to teach, how we need to teach, how we need to structure, okay, and why we need to teach them. Can we omit them? And so we paid. So what happens here is, for every class, we will have hands-on. So I will walk through some of the sample exercises. Then I will give additional exercises for you, so you can practice them. And on a next day, I will pass you the solutions for all those exercises. Okay. So if you can check if your solutions are right or not. If they are not right, you can go through that. If you have any questions, we can discuss them in the class. Okay, this happens for every section. But we have a couple of case studies, like a mini projects. For every algorithm, we do a mini project. Okay, one project one algorithm we will run through in the class, and you will get exercise based on the available data sets. We will use the real data sets from the internet. There are lots of data sets available in internet, so we use one of the real data set. And also we will have two major projects. One project is on the analyzing the data, and one project is on the machine learning. And this project on the machine learning is like a very huge project where we need to generate a report. So because it's not just analyzing data, you have seen the Venn diagram. Computer science is the one, and the business is one, and the statistics and mathematics is one. So we need to show our computer science skills, our mathematics and statistics skills, and we have to show even our business side skills. So how we need to show? So we need to develop the algorithm, we need to analyze the data, we need to create a model, then we need to document this model, which is helpful for the business. So we will generate a report for the final project. Okay. And also what we are doing exclusively for this course, we are conducting an HR session. So I know I'm working in data science for last few years, and I'm in analytics for last 17-18 years, but it doesn't mean I'm very good in writing my own resume or finding my own job, because I'm not an HR. If I apply for 100 jobs, maybe I will be shortlisted for 1 or 2 jobs, and I don't know even why, because HR is the right person to guide you in the market. So we are going to have a session with one lead HR who is from the MNC. So he will guide you through the interview process, how the interview happens in the data science. This HR is from the data science who is working in Singapore. So he will also tell how your resume should be, so that when HR looks at your resume, they will get attracted. So we don't do the resume. Okay, the HR will guide you. It will be a 1.5 hour session. Okay, so we do that. Okay. And coming to the course content, we start with the Python. Why we start with the Python? Because Python is easy to learn. Okay, then we go with the mathematics. In mathematics, you don't learn all the mathematics. You will learn linear algebra, you will learn a bit of calculus, you will learn probability and statistics, only 4 items. And also you don't learn every topic in detail. We will learn only that is required for our algorithms, all the algorithms. Okay, we start from the basics. Okay. So if you don't have any mathematics, you did not study mathematics at the after 10th class, that's fine, because most of the mathematics we are going to study is high school mathematics from class 8 to 10. Okay, then we go into data analytics. Data analytics, nothing but how to analyze the data. So you know a bit of mathematics and statistics, and you know a bit of Python. So we use Python here to analyze and to showcase your mathematics skills and analyze the data, and how to work with the various data formats. Because remember what I said earlier, this is the time where data scientists spend more time. This is the stage. They need to clean up the data, they need to arrange the data before they apply any model. Okay. Then we go to the unit 4, machine learning. So we will learn a lot of algorithms here. All these algorithms that we are going to learn in Python. Okay. So once we learn all these algorithms, then we go into the R. So whatever you have learned here, Python as a language, and this data analytics with Python, you will learn again with R. Okay, so this unit 1, unit 3, and unit 4 repeats in unit 5. But we will be a bit, we will speed up the things here, because you already know all the algorithms. So I don't have to teach you again the algorithm. So we just see how to implement the algorithm using R. And once you learn Python, trust me, R will be much simpler for you. Okay, because both the languages are a bit same. You just need to learn the syntax of other language, that's all. Okay, then we learn big data with Spark, with Python. Okay, we learn basics of big data, and we learn Spark, not 100% of Spark, but we learn some 50 to 60% of Spark, but we use Python. There's a package called PySpark. So using that package, we will analyze the data and we will create some RDDs. Okay, so do you have any questions on the course content? Because this is quite important for you to make any decision on this course. So you can post the questions. Meanwhile, I will proceed with the next session.
Kishore, let me check with others how many people are fine. How much time it is going to take?
When the new person heard about algorithm, after learning about few algorithms, then we will see some code in action. Okay, so let's see data science in action. Okay, guys, there's a question for you. This is like let's play like a game. I have group A and group B. Okay, so here I have this picture, two people sitting inside a car. So I want to know if I need to put this picture in group A or group B. I'm just trying to categorize the data images here. So do you think, where should I put this now? Group A or group B? Okay, I can't see your responses, but let me summarize. So here you don't have enough data. You don't know what is group A and group B, so you don't know how to put. So let's see. I give you some data. I have one image here in group A, one image in group B. So now where do you put this? You may put it in the group A, or you put it in the group B because it has a car, because group A is not car. But you are deciding based on one example. That may not be enough. We may need more data, right, to have the more accurate, to categorize more accurately. So I have additional data. Now group A also has car. So where do you put? So I see, oh, what is the other difference? I have people, right? In the group B, both the pictures has people. So should I put it in group B or group A? So now definitely your answer may be group B. Let's see more data. See this one. If we decide based on that first two images, third image confirms it. Yes, I should put it in the group B. Then see the fourth image. I have no people there. Should I still put it in the fourth group B? See, as we have more data, our decision, becomes more accurate. So you will, if you have more data and you try to analyze the more data, you may make a right decision. If you make a decision with one or two samples, you may not have a good insight. That's why people need more and more data. We will learn more about this when we learn the statistics. Okay, so let's see another example. Here also no people in the car. So now I am confused whether to put in group A or group B. So this is my final image. So based on this, where do I put? What is the common? Where do I put this image, group A or group B? Group A has all cars, group B has cars with people and without people. Okay, where am I going to put? I'm going to put in group A. Why? Because in group B, if you see, all car doors are open, right? Here we have all the doors, all the vehicle. I can't say car because we also have a two-wheeler here. So I say doors are closed. Whereas in the group B, we have wide open. So this is nothing but an algorithm. If I tell this to computer, I need to instruct. If I want a computer to do this, a machine to do this, I need to instruct the machine to do this. That instruction is nothing but an algorithm. Okay, let's see more. What kind of algorithms we have in machine learning? Mainly we categorize into supervised, unsupervised, and reinforcement learning. Okay, In supervised, we have regression and classification. In unsupervised, we have clustering. Okay, just now what we saw is classification, which is the supervised learning. Okay, which is the supervised learning. We are trying to classify. The difference between supervised learning and unsupervised learning is, in supervised learning, you know your outcome. Okay, here I know my outcome will be either group A or group B. Let's say I want to predict the housing price. I know my housing price, when I predict it will be some kind of price, and I'm predicting the housing price. So which is regression. So classification is the discrete data, yes or no, or I want the fruits, either the fruit is apple or mango or banana. I want to classify. I have a new fruit. I want to decide if this fruit is banana or apple or mango. So it's a discrete in nature. This is discrete, and this is continuous, like housing price, right? And clustering. Clustering is nothing but I don't know anything. I don't know my output thing, but I want to find something. Let's say I will show you one example for this. Okay, have you seen this website, Google News, news.google.com? What's happening here? This is my first story. They call them as stories. See here, this news is coming from New York Times. Okay, this news is coming from highly cited, it's a Bloomberg, another website. This news is coming from Washington Post, CNN. So what's happening here? See, this Google News is a bot, a machine learning algorithm, which is a cluster. So it goes to all the websites, it searches, or it gets all the news, all the top news, and it will try to group them together. See, before it does this, the algorithm doesn't know what it's going to pick up, right? So based on the common words, it will try to put them together. So this is nothing but our unclassified, our clustering, unsupervised learning. Okay, in supervised learning, we will train the algorithm. We will give the algorithm, we will feed the algorithm with some data, we will train it. But in unsupervised learning, we don't have data to feed. It will find its own data and it will categorize. It will put the data into different clusters. In this case, it is a different stories. Then reinforcement learning. It is nothing but self-learning algorithms. If you have seen my introduction video, we have been talking about the Google AlphaGo, which is playing a game. So that is nothing but reinforcement learning. How does it learn? Let's say playing a chess, that could be a reinforcement learning, because for every move the computer makes, if the move is a right move, it will be rewarded. It will get some reward. So the machine thinks that, oh, this is a good move. So next time in the similar situations, it will make that move. If the move is wrong, then it will be penalized. So that's how this reinforcement algorithms work. So you can see there are only 3 kinds of algorithms. Among these 3, in supervised learning, we have 2, regression and classification. Okay, let me quickly run through another example on the classification. So I'm going to have some sample data. Okay, I want to know based on the hair length. Let's say hair length is 10 centimeters. Okay, if hair length is greater than 10 centimeters, I want to say male. Sorry, if hair length is greater than 10 centimeters, let's call it female. Okay, if it is less than 10 centimeters or even equal to 10 centimeters, we will say male. Says this is 0 and this is 20, and this is just the count of the person. How many persons? Let's say first person, second person, third person, fourth person. Let's say up to 20 persons, right? So the 10 centimeters will be somewhere here. So my first person length may be some 5, right? Okay. Second person length may be somewhere here. So I may have some data like this, right? Every person will have different data. So whoever below, so does it make sense? So I can draw a line. I can say that these are the male and these are the female just based on the hair length. But it's not common. Some males may have longer hair. So if I have a male here and if I have a longer hair, I'm classifying him as a female. So my algorithm goes wrong. So what does it say? Even though we are trying to classify, we are applying an algorithm to classify the data, there is not enough data. So based on the hair length, we can't just confirm, right? Let's say another example, same thing. I'm still using the hair length 10 centimeters, okay, and 20, 0. But instead of just counting the persons, I'm using the height. Let's say until 200 centimeters. So it's easy. Let's say if the hair is longer, so we have two algorithms now, right? So we have greater than 10 centimeters, okay, and less than 10 centimeters. Okay, we are saying female and we are saying male. But here we have another feature. Normally we call them as features. Every property is called as a feature. We have a height. So let's say if we have a male who is let's say if you have a female who is greater than 20 centimeters, 10 centimeters, we can also check for height. If the height is more than 150 centimeters, right? If the hair is longer, so we can classify male or female. So we can, let's say I'm classifying height 150 centimeters somewhere here and 10 centimeters. So even the hair is long here. If the height is more, I will consider this as a male. So my range will be now like this. Okay. Sorry. My range will be, so all females here, all males here, right? Okay, based on the hair. But if I have anyone with the height, they are more height, so I may have male here. Okay, so I may have male. Some females may have a short hair also. Some I may have here also, some females. So and this is also not enough. We need more data. Okay, so this is how you classify. This is why people need more and more data, more features. So all this is I'm trying to classify. I'm using the same draw a line. So this is nothing but a regression. So what we do is we will take the house. If let's say I want to buy 110 square meter house, my price will be somewhere here. So I need to pay this much, this amount, maybe 800,000 or 750,000. That is my prediction based on the regression. So these are very simple algorithms. So these outliers, to analyze, we need more data. Why it is like that? And we may consider that if we have more data, because we are only considering two factors here, square meters and the price. So I may have more data, additional parameters. So based on that, this chart may change if you have more additional analysis. Normally, it is not easy to draw more than 2 dimensions on the chart, but using Python or you can very quickly do multi-dimensional regression analysis. So these are the algorithms. I'm just giving you an example. What are the algorithms are? They are not so complex. So we have around 14 algorithms or 15 algorithms. So they are not very complex. It's easy to learn. So you just need to understand what is regression, how to draw this regression, and how to calculate this. Okay, not just calculating this. Is there any error? Let's say I am paying 800,000 now, but am I paying the right price, or am I paying more? If I am paying more, how much more I am paying? If I am paying less, how much less I am paying? So there is some error number. So let's say some 50K is the error. So we can calculate all those things using statistics using Python. So this is about the algorithms. Let's see a quick demo. This doesn't take much time. I just want to show you the regression, whatever we have discussed in Python. Okay, this is a very quick demo. So don't worry about the code. This code, what I am doing, if you are familiar with any other languages, you already know what I am doing here. I'm trying to import additional code which is stored as part of this package. Okay, if you are in C, C++, you use #include, right? So this is additional code, and I'm reading a CSV file called housing.csv, which is here. Okay, I'm reading the CSV file. So when I read this file, okay, this is I'm just listing the head. So head means it will list the top 5 rows. So this is my data structure. Okay, let me go and show you what is my data structure. Okay, see, this is my data structure. Okay, I have address, I have price, I have area. See, I have how many features I have? 5 features. Address, there's nothing much we can do with the address. Okay, we don't choose address for any as a feature, but we know the area. Okay, so we have few parameters here. Okay, house age, what is the age of the house? Okay, area, number of the rooms. Okay, and income of the area, how much people earning in that area, and number of bedrooms, how many bedrooms, and what is the population of area, and what is the price. See, I'm trying to do regression based on 1, 2, 3, 4, 5 features here. Okay, this is my data set. So these are the top 5 rows. Okay, so the first thing what I'm doing is I'm trying to describe. Describe means it will analyze my data set and it will give you some statistics. So you don't have to write all the statistics. You just need to understand. Okay, you don't need to know how to calculate the mean, standard deviation, or minimum, or 25% or the quartiles. You don't need to know how to calculate, because the system calculates for you. The programming language calculates for you. But the only thing you need to know is how to interpret. you need to know what is mean, what is standard deviation. Okay, when I say this is standard deviation, this is mean, what is the difference? What's happening here? Why there is a huge gap? What's happening here? So you need to understand all this. So you need to try to get the insights out of the data. Okay. See what I'm doing, I'm just trying to draw all the plots using all the available fields. Okay, see, this gives you insights of your data at one glance. Okay, see, I have area of income and the price chart. Okay, I have area of income and area population. See, we have just studied the regression. If you see the regression, this is a bit regression, right? Price and our area income is both are related. If the area of the income increases, price is increasing. Okay, but here see, if the area of the population is increasing, area of income is increasing, it doesn't make much sense. The data doesn't show me any meaningful insights. And here see, number of bedrooms by price, it makes a bit sense, because if it has 2 rooms, the price is lesser. If it has 3 rooms, 4 rooms, 5 rooms, 6 rooms, the price is bit changing. Okay, see, this also they can make some. So based on this chart, right, very simple chart, one simple command, you can analyze lot of things. See, this chart looks better. Okay, this is between area, income, and the price. It is the same thing. Okay, so Python, it's such a simple. How many lines of code we have written? 1 2 3, that's all, 3 lines of code to get all these insights. So if you want to do same in C, C++, you have to write many lines of code. Okay, let's see. What am I doing here is, I am taking my X and Y. See, I have all this price. What am I trying to predict? I'm trying to predict price. So price I am taking into Y, because that is what I want to predict. So what are my features? What are my inputs? I am giving it to X. So all the columns, so entire data set I am assigning to X. See, it's so simple in Python. I can assign 5 columns of data into one variable. Okay. So next, what am I here doing is, see, when you do any algorithm, we have said you need to train the algorithm first. Then you need to test the algorithm to see if the algorithm is working fine or not. So that's the reason why we split data into 2 parts. We use first data set to train the data, then second data set to test the algorithm. Okay, and then we start predicting. If you don't test, you are not sure if your data going to be right when you predict it. So you need to have some data with a known price, so you can in future your algorithm, your model going to predict it. So what am I doing is, I'm just splitting into train data set and test data set, both for X and Y. Okay, using this data set, I will train my model. Using this data set, I will test my model. See, this is where I'm creating my linear regression model. Okay, and I am training the model now. It's only one statement. You don't have to write hundreds lines of code to create algorithm. This is the model, this is the training. So that's why it's so easy for big companies to create like Azure, SAP, Leonardo, and to sell in the market. Okay, so once I train the model, I'm trying to predict data. Okay, let me try to execute first, because so far I did not execute this. Let me try to execute so I can show you the sample. Okay, when it shows star, it is still executing your code, because it's a very huge data set. Takes a minute. Okay, so what I'm going to do is, I am assigning to X and Y. So rest of the execution should be quite fast, because your data is already in the memory. So that is another advantage. So when you're trying to analyze, so you need to have the high memory in the system. So if you are trying to use your laptop or desktop for this course, I suggest you to have at minimum 8 gig of RAM, and recommended is 16 gig. But if you're not, anyway, you're not going to work very huge data sets while learning, so 8 gig should be fine. Okay, I'm executing the model. So creating the model is quite fast. Then I'm training the model. It's quite fast. So I have trained the model now. So I'm running the prediction. Okay, what am I doing now? Now I'm trying to predict my results using the test data. Here I have used my train data. So training is done. Now I need to test. See here, what am I trying to do is, I am trying to do a scatter plot between my test data and the prediction. So I'm trying to compare, because whatever the predictions I have got from my model, I'm not expecting 100% right. But see the data here. I have my Y and my predictions. So they are very linearly matched. So they're almost close. Okay, let's see some sample data. What am I doing here is, okay, I'm reading another file called housing1.csv. It has only 5 records in the file. Okay, and I have the price here. So let me open the Excel file. So the model is trained now. Now we can use. So this is our final step for today. See, this is my data. Okay, this is my test data to predict the price. Okay, so let's see how good our model is predicting the price. Okay, see, I'm reading the read CSV. I'm reading housing one, and I'm displaying the top 5 rows. Okay, anyway, we have only 5 rows, and I assign X1. I'm not assigning Y here. Previously, we have assigned Y here because we need to train. For testing, we have tested this here just to confirm it, but now I'm trying to predict. So when I predict, I really don't need to have the price. Okay, so instead of drawing this chart, I want to compare manually. Okay, I don't need Y, so I'm collecting all my predictions into predictions 1. And what is my output? My output is this one. So price for my first house is this one. Is it close? Let's see my data. What is the price of my first house? 1059. It's pretty close, some 30,000 difference. And the second one is 140, predicted by my model, and my actual price is 150. See, we are predicting very close. It's not very way off. 122,000 have predicted, and here 10. So the more data you have, you can predict better. So whatever is the difference here, the difference could be an error, right? So it is so easy. Now using this model, you can predict the housing price. So I can just go and see based on the average, based on the 5 features, number of rooms, income, and the area of the house. So I can predict the price. And let's see, I think there is some 20,000 to 40,000. That's not much, right? So you can make your decision with the data. Instead of if your agent asks, oh, pay me 100K more. So you don't have to pay because your model says the price is predicted price only this much. The difference is not much based on the current, data set. So that's why people believe in data, right? You can predict something. You can predict the future, right? So any questions so far? So that's why people say predicting the future isn't magic, it's artificial intelligence. And what is AI? Is it different from data science and machine learning? So it's completely, again, actually all these terms are interchangeable with very, very little difference. So we will learn more on the AI later on in the classes. The final Q&A session for a day. But this is a must.
So you mean
basics.
You mean to say this is a basic?
I'm not saying basic. It's a base. It's a baseline for your learning. It's like your stepping stones.
Okay.
How to say, like a platform for your house.
On top of it,
so
they can learn one more tools or the language.
On top of that, you can actually learn based on the company you are working, what tools they are using. Based on that, some tools you can learn on the job. You don't have to learn all the tools, but this, whatever the course that we are covering, you must learn.
So regarding the the cost of the course asks, I mean, actually,
Yeah, Kapil.
Yeah, hi.
Yeah, bolo.
Yeah,